Hey guys, welcome back to the channel. My name's Jay Wilson. I hope the background noise isn't too annoying, but working out of the coffee shop, so enjoying that best coffee shop life. Um, One of my good buddies, Mark, asked me the other day to put together a data set that showed him all of the tiles that were in an ETL, and I was like, that's cake. And I did it, and it was great, or at least I thought it was great. And then he started getting fancy. He was like, well, Jay, this is good, but how do I know which tiles are the slow performing tiles? How do I know which data flows to optimize? Mark, that is a much more complicated question that's going to involve considerably more code, but why not? Let's talk about it. So, at the end of the day, his question is not how long does it take the data flow to run? His real question is, how can I make my data flows faster? That's his real question. And I guess in order to answer how can I make my data flows faster, I think you need to know what are my slow actions. And in order to know what are my slow actions, you need to know how long does it take an action to run, which is somewhat useful. The harder part is you're like on average, right, or median, whatever calculation you use. In general, how long does it take an action to run? And in order to know that, you have to look at execution history. Oof, right. I hope you're just like hearing more and more APIs pile on that we get to query. And Mark, I hope you appreciate how non-trivial this task was to ask me. But, knowing how long a tile takes to run is just kind of half of the story. We might ask ourselves, why? Why did it take a tile to run as long as it did? Is it just because a bunch of rows went through it, or maybe there's a different culprit? Magic ETL has amazing optimization in place, and one of the things that can really impact tile performance is the parents. How many parents did a tile have, and more importantly, which parent tile took the longest to run? Okay, and with that summary out of the way, am I recording? Please be recording. And with that summary out of the way, hopefully you have an idea of just how sophisticated this request is, and maybe an idea of how much code we get to write. So I did a lot of extension to DomoLibrary and added a whole bunch of new root functions to the DataFlow function. So let's take a quick look. Get DataFlow by ID, that was already there. It would return to us information about the current state of the DataFlow, including are these actions? Why can't I see the word actions? Well, get data flow ID by ID would give us information about the actions, including, hey, what is the action itself, but also what is the dependency, or what are your parent tiles? Now, in the case of a SQL-based data flow, it's all linear, right? One depends on the previous. But in Magic ETL, you can imagine one tile could have multiple parents, so this depends on list would include multiple tile IDs. Fantastic. We also added the ability to retrieve the data flow versions. And right, as you know, every time I edit a data flow and push save, I create a new version number. Okay, that's not exciting yet. What I need to do is I need to be able to retrieve the data flow definition based off of a specific version. So give me the data flow definition for data flow number 123, version 12345. And again, that's going to now give us our actions. It's going to give us the tiles it depends on, as well as the definition of the tile. But you'll notice it doesn't have the history or how long it takes the tile to run, and that makes sense. This is the definition of the ETL, not X. Okay, we're back to recording. All right, so let's go through here. The next thing we needed to do is we needed to get the data flow execution history. So the history of the data flow will be like, all right, I have is this execution history? Yes. Ah, yes. And then how long did it take? Oh, I see what happened here. I'm printing the first execution history, not all of them, right? I was expecting a list. That's why I was a little bit confused. But you can see here, as I look at the execution history, I can see here's one execution event. Here was the begin time and end time, but it doesn't tell me anything about the tiles. I need even more information. So I hit a different API that says give me the execution by execution ID. And now it actually says, hey, for this execution event, here are the action results, right? So here's my publish to vault tile. It started at this time, ended at that time. But notice, while I do enjoy having my execution history, it doesn't tell me the dependencies of this tile. Remember in the previous tutorial, I said you have to think about like what APIs do I have to hit, and maybe answer the question, do I have to hit two separate APIs? Do I need to go one place to get the definition of the data flow, and a second place to get the amount of time a tile took to run? And then how do I mash that up together to give me the data set in the correct shape? Again, Mark. He's like, sounds like an easy question, doesn't it? Here we go. Let's go through this code. So we have authentication, fine. We can get a data flow by a data flow, or sorry, we can get a list of data flow IDs by searching the data center, which again, we talked about in the previous tutorial. I won't spend too much time here. If I have a list of data flow IDs, I can, for each data flow, get the data flow definition by ID. And again, this just gives me high level information about the data flow. It doesn't actually give me the history or the execution history. But because I'm using classes, I can build classes that have methods, and those methods can do additional stuff. So I extended the get from ID class method to retrieve not only the list of actions from the current state of the data flow, but also create placeholders for retrieving the versions, the version definitions, as well as historical execution. All right, so what does that look like? I wrote a function called generate version action PDF. And what it will do is it will receive a data flow. And with that data flow instance of a data flow, I can call the function get versions. Call the method get versions, and it will get a list of data flow versions. Let's just see what that looks like. So here, when I return, that did not do what I expected it to do. Here we go. Okay. So data flow versions is a list of Domo data flows, but this is version 1, version 2, version 7. And it includes now the actions. Yes, it includes a list of actions for that version of the data flow. And right now we are looking at version, the version 1, which is also the same as 47. Okay. Cool. So I have a list of data flow versions. I now need to take that information and turn it into a data frame, right? How am I going to structure my data for reporting? And so what I said is for each action in data flow, for each data flow version, I want the ID, the version data flow name, and then information from the action itself. And again, as I return that, that gives me the data flow ID, data flow version, tile ID name, and a list of parents. What are my dependencies? Cool. With that in place, I can also say, all right, I have the definition covered. Now, how do I handle execution history? So again, this function is going to receive a data flow, and I'm going to say, we're just going to look at the last 10 executions. I could have looked at 20, 100, but whatever. We'll just focus on the last 10. So for our data flow, we have a history class, and it has a method called getExecutionHistory. So what does that give me? When I get a data flow history execution, that gives me the ID of that execution history, the data flow ID. and then information about the execution event, right? How long did it take? How long did it take to end? What data processor type? But most importantly, the part we care about are these action results. The action results saying the number of rows processed, begin time, and end time. Again, if you're wondering, Jay, where did you pull all of this stuff from? I'm a genius. If I go to a data flow, obviously this is the execution history. And if I get the execution history details, here are the tiles that ran, how long they took, right? That's the stuff we're interested in. But again, you'll notice here, again, it doesn't say what the dependencies were. We actually have to edit the data set, get the data flow definition to see the dependencies. And now we can hopefully see how this is all still coming together. All right, but coming back to execution history. Once I have my execution history, I do have some error handling in place to say, hey, what if I didn't run this data flow? So I have a test to say if there is no execution history, just return an empty data frame. But otherwise, for each action tile in my history, these are the columns that I want to keep. Here's some columns I want to rename and stuff. And so I get a data set that looks like this. What is the data flow execution ID? What is the tile ID, tile type? How long did it take? Again, you might say, you know what, this is great. Let me put this into a data set, and then I'll just publish it, process it in Magic ETL. And originally I did try doing that, but Magic ETL was giving me problems, so then I got to rewrite my code in Jupyter, but we'll talk about that another time. So I have when I write DomoStats datasets like this, I usually have a function called process instance or some way of kind of like stitching it all together. Because what I usually do is I have like 5 or 10 or 100 Domo instances that I need to capture this kind of data about. So maybe I'll just pass in instance authentication. And okay, I have a function that says get all of the data flows in this instance. Sorry, get all the data flow IDs, then get all the data flows. And then for each data flow, we are going to generate the actions PDF and the execution stats data frame. I don't know why this is PDF. That should just be data frame, but okay. And then to kind of see the work in progress, we'll just print that to a data set living in Domo. So let's take a quick look at that. Here's my DomoStats data set. And the DomoStats data set says, hey, here's this data flow execution event. Here's this tile. This tile took this many, started at this time, ended at that time, and took this many seconds. And this might be good enough. You might just say, hey, sort this descending, and let's just find the big offenders. We could have duration and second is null. Come on. Can I have descending, please? Okay. So target these data sets, these tiles, and say, hey, tiles, what's the big deal here? But again, while this is a good start, it doesn't answer what was the impact of the parent, right? If I had 2 or 5 parents, which one is the responsible culprit? I don't have that in this data set yet, and so now we need to get into the place where we shape the data set to do the thing. Oh, I wrote a function called generate datasets. It's going to receive the actions or the definition list, and then it's going to receive execution history. And then for testing, I can pass in a data flow ID or an execution ID. Okay. So, I have a test data flow ID and a test execution ID. Let's go. First thing I did is apply filtering if I'm doing some testing. That's fine. We'll ignore that. And stats data frame is basically my execution history with a couple descriptive columns like tile ID and name added in. Merge is the same as a join in SQL, so that's why you'll see that. The first challenge was to say, okay, I know that a tile can have multiple parents, so I want to have one row per data flow, execution, tile, and parent. So I use the explode function to generate one row per member of depends on. And let me show that to you before they explode. So I'm going to return actions df, right? And what does actions df look like? It looks like a list of the action definitions. And remember, the depends on tile is a list of parent tiles. After I handle the explode, I have one row per tile. And so is this duplicated? Yeah, so this is the same tile ID, but the parent tiles have been split out. Cool. And then take my explode information. Yeah, so here I can take my fact, the fact being information about the tile execution event, including the data flow begin time, end time, and duration, and join it to my explode, right? One row per parent, and I can add in the parent stats. So let me just really quickly return facts by parent data frame. So here I have same thing again, right? I have one row per data flow version, and if the tile had multiple parents, like this guy here, I can see, okay, join data had 2 parents, and those parents were loading the data, and they had different number of rows processed, and this is actually kind of interesting. The parent end time, this one ended at 10:52:56. This ended at 10:52:54. And I think this moment here really cleanly articulates the need for this approach. So let's take a quick look at data flow ID 18. Look at data flow ID. So one of the things that makes Domo so powerful, especially Magic ETL, is that there's a lot of optimizations in place under the covers that allow things to happen in parallel. So in traditional SQL data flows, whether it's the MySQL data flow or the Redshift data flow, this join event would not begin until this tile was completely loaded and that tile is completely loaded. But because Magic works the way it does and it's not operating in a database layer, it says, hey, as long as data has started arriving from both points, I can attempt to do a join. Or in the previous data flow, I think I said this already, in the previous data flow, hey, I can start to do a union as long as data has started to arrive from here or data has started to arrive from here, right? And so again, the parent tiles might have different end times, and so the actual amount of time that this tile added is probably the difference of the last tile's execution. What was the end time of this tile minus the end time of that tile, and vice versa. And so that's what we're working on in this step here. We're saying, hey, the parent end time should be the parent end time, and if there was no parent, what was the beginning time of that tile itself? But then I say the actual duration is the end time of the tile minus how long it took the parent, that specific parent, to end, measured in seconds. And that's going to be my actual duration tile column. And then I just do a quick rank per tile ID. If I had multiple parents, rank the actual duration to see which of the parents took longest or had the most impact. And that's our output data set. So do I have an example in this preview right here? Let's see. Okay, so here's my join event, right? Same tile ID. It's got 2 parents. It's got this loader and that loader, and the parent and, oh, sorry, I need to run this again. Let me remove my return. Where were we? Here's my join. Here's my loader. One parent had 45,000 rows. The other parent had 46,000 rows. I would actually expect these to take approximately the same amount of time, 56 seconds and 54 seconds. So this tile took 2 seconds longer functionally than the other tile, right? Or added that much to the parent. And so this one is the culprit. This is just chance at this point, right? 45,000 rows, 46,000 rows. Maybe I should do an average over, or a median over all of the execution events. But hopefully you can see, like, this gets us in a good place where we can start having an intelligent conversation about which tiles really take the longest to run. And then we can write that into a data frame. Mark, take notes. This is for you. You're welcome. That's our tiles exploded data set. Cool. Again, what does this allow us to do? It allows us to pick any data flow. So I think we were looking at 108. So here's a data flow. It's been executed several times, but I can just pick one at random here. So I can say, hey, let's take a look at this execution ID. I can say, hey, this action had, Python script had 2 parents. The parent tiles were 2 select tiles. And each of these select tiles looks like had a pretty negligible impact. Well, 8 seconds. Wow, that's a lot. Wow. So had some impact on tile execution. Anyway, hope you guys found that helpful. I think there's 2 big questions that we were kind of working through here, right? Is like, we started with a broad question. How long does it take a data flow to run? We try to break it down into smaller pieces. Like, if you had to answer this question by hand, how would you do that? Go to the user interface, show me where you would pull that data. From there, we said, okay, how do I turn that into a root function in DomoLibrary, or how I can extract that data from Domo? And then how would I format that into a data set that actually allows me to answer the question and ultimately make my data flow run faster? My name's Jay Wilson. Hope you guys found that useful. Catch you guys later. Peace. Bye.